talking about Virtual SAN 6.0, and we have the always awesome Rawlinson Rivera, also known as Punching Clouds on Twitter. I'll be your host for tonight. My name is GS Kalsa on Twitter at Guru Simran, and yeah, we're getting started a little bit late here. We ran into some technical difficulties, but all ready to go. If you have questions during the show, you can put them in the questions panel or chat, or I'll also be monitoring the vBrownbag hashtag on Twitter. So however you want to get those to me, and I will interrupt Rawlinson and ask your question and throw in some questions of my own. So with that, Rawlinson, it's all you. Take it away.
Let's do this straight from the casino floor at the Palazzo, because that's how we do it.
Awesome.
So let's talk some Virtual SAN, folks. Obviously, Virtual SAN is a software-defined storage solution delivered by VMware. If you don't know about this now, you've been living under a rock that is probably heavier and deeper than the one that the guy, Captain vSAN himself, has been living under. For the most part, Virtual SAN is basically a solution that not only delivers a different approach to the managing of storage consumption, managing and operation, but it delivers efficiency in terms of an operating model, which now today, as part of the VMware strategy, is being adopted across and beyond Virtual SAN itself to something we call vSphere virtual volumes. But today, the topic will be Virtual SAN. One of the things that is very unique about Virtual SAN, which is really important to focus on, is the control plane that is delivered and utilized in Virtual SAN, which is basically how we now make all the different storage capabilities available on a per VM basis. So basically making the system to be somewhat of an app-centric sort of control plane that it consumes, which is able to leverage these capabilities across different tiers per se. In this case, when it comes to the different devices that are attached to individual ESX hosts. Virtual SAN particularly leverages three different types of capabilities, which in this case are capacity, availability, and performance, as you can see on the screen here. And those are the three different capabilities that can actually be utilized within Virtual SAN in the form of a resource that can be consumed in many different ways. So what is one of the big and important things about Virtual SAN? One of the things that we're trying to do with this, beyond the concept of just introducing another form of storage technology, is into introducing a better way of consuming the storage systems, consuming the capabilities that are out there. Particularly when you look at some of the challenges that we experience today in reference to traditional storage systems where, you know, they're specifically defined to specific hardware-centric, vendor-specific management constraints in terms of the provisioning capabilities of some of the systems. Depending on what they are, they have somewhat of a rigid sort of storage construct and configuration types. These things, we call them normally as LUNs or volumes. Now, one of the things that are very commonly assigned to these volumes is the concept of data services, the features that your storage arrays kind of deliver today. That also requires, in times, a lot of different frequent data migration, which happens from systems to systems whenever the footprint or the workload type or performance or profile of a particular application changes, which requires moving data from one data source to another. That obviously introduces risks. It exposes us to having to have the requirement to be in, to manage LUNs, be in the business of managing LUNs, which again introduces complexity and a lot of different things we have to deal with. Virtual SAN's focus is around being able to get around all those different complexities from an operational efficiency perspective. With Virtual SAN, we deliver fast VM-centric provisioning capabilities. There's no need of carving LUNs or volumes because now we're talking about a single data store that can be consumed throughout an entire cluster. And in the resources and the different data services that are available can be automatically provisioned and maintained throughout the life cycle of any particular application or virtual machine and their individual objects. Obviously, when it comes to being able to change the workload profile of a particular object, you can do that dynamically, and the system will adjust, deliver the actual requirements that are being asked at that particular time. This is the power of being able to deal with policies and kind of moving away from the silo approach that we traditionally manage and deal with storage systems today. So overall, Virtual SAN today, now in the 6.0 implementation, we now support two different types of architecture. The hybrid architecture, as the one we released in 5.5, very capable, same concept here. We deliver a solution which runs on a standard x86 software. It delivers a performance enhancement by leveraging the use of caching device, flash-based devices. New to the platform now, particularly here, is the level of performance and how we've improved the amount of IOPS that can be delivered in the hybrid solution. Now we're talking about doing 40K IOPS per host in a solution that is resilient. It's still focused on delivering and reducing single point of failures from a hardware perspective, and still remain tightly integrated with the rest of the VMware stack of products and solutions. It's very powerful in that case, so that we don't have to actually leave the sort of solution, manage it a different way, which makes it very appealing for folks that have already, adopted and have the knowledge of vSphere, so they don't have to learn something completely new. The new architecture supported now with vSphere, with Virtual SAN 6.0, is the all-flash architecture. The all-flash architecture is pretty unique, where now we're introducing a two-tier model in terms of flash tiers, where one tier, known as the caching tier, is utilized now as a 100% write buffer. So we can actually outfit this tier, per se, as we call it, with write-intensive devices that can actually outfit that, fit that model and that use case there. Whereas the persistent storage can leverage, a lower cost, read-intensive type of flash device, which that translates basically into cost savings, because you don't have to have, the same high-end device with the two different tiers, which then delivers a cost value there. When it comes to the performance aspect of this solution, we're talking about an incredible amount of IOPS per host, 90K IOPS per host. And while that's really nice and fancy, one of the things that I like to focus the most on is the one bullet point below, which is basically being able to deliver that level of performance consistently at sub-millisecond latencies. Why we're now with Virtual SAN, we're kind of targeting a lot of different use cases in applications, and the different workloads requirements can now be satisfied with one of the two different architectures that we have in place. To compare what Virtual SAN 5.5 and what it can do now with 6.0 in terms of enterprise scale, class, and performance, you can see here that with the two different architectures that are now supported in 6.0, we've basically been able to double up on just about every aspect of the platform. 64-node support, 40K IOPS for the hybrid, 90K IOPS for the all-flash, and in terms of the VM host consolidation ratio, we now support up to 200 VMs on either of the architectures, and a total number of VMs up to 6,400 VMs per host, right? That's in the actually fully maximized cluster in that case. Because of some of these facts, we see that in terms of what are the use cases for Virtual SAN 6.0 today, one of the things that we sort of held back on the previous release of the 5.5 was the full-blown approach on business-critical application support. Well, because of the scalability, performance, and now the different, how much more the system can actually deliver, one of the main targets for Virtual SAN is business-critical application. If you virtualize an application in vSphere, it should already be able to run on Virtual SAN, because we can deliver the performance, the scalability, and the capacity that is demanded by any virtualized application that exists today. Just about. When it comes to the hardware, obviously, there's a lot of things that we look into here, and for the most part, when it comes to Virtual SAN, there are a couple of components that are very, very, very important. Obviously, the servers themselves, they, once they exist and are part of the vSphere compatibility guide, they're pretty much good to go. But for Virtual SAN specifically, we have to remember that the devices that are going to be put into the system are very, very important. We recommend for everyone to make sure that any device used for Virtual SAN has to exist within the VMware compatibility guide, specifically for vSAN. If there are a couple of components that I would recommend and tell folks to pay close attention and look at, I will focus basically on the controllers. Obviously, we can support controllers that support the RAID 0 modes as well as the pass-through mode. We recommend for the pass-through mode to be the the preferred setting. That way we can control all of the actual hardware and components more efficiently, and it'll also lead to better operational impact in the event of failures when it comes to replacing devices and whatnot. With the different flash devices that may exist, obviously we have developed a classification for the type of devices that should be used in the different architectures based on their durability and level of performance. Obviously, some of these things should always be confirmed with the VMware Compatibility Guide as things continue to change. There's a lot of new devices that are coming to market now, which will have an impact on the performance as well as the durability of the devices that you use for the solution. For the most part, obviously the virtual SAN hybrid architecture is still pretty much the same as it was in 5.5, obviously more capable now in terms of performance. So when we look at the role of a flash device on the hybrid architecture, place dual roles here where there's a write buffer and a read cache, and we split them in the numbers that you see here in order to deliver a sustainable amount of performance that can scale and be distributed throughout the whole cluster. Now, one of the things that I also like to highlight to folks all the time is, you'll get what you pay for. If you're looking to get or add devices that are not within the ACL, that are low performance, that are not, designed to do what you expect them to do from a solution perspective, they're not going to give you that. You're not going to get that. So obviously, hardware choice is the #1 differentiator between the different configurations that you may have, and it's very important. It's obviously something that I make a point to point out to folks every time I talk about this. From the flash device perspective, the all-flash architecture, here we're dealing with two different types of tiers, a caching tier and a capacity tier. We talked about the devices a little bit when it comes to being able to have high-endurance flash devices for the write buffer, maybe a lower-endurance type of flash device for the capacity tier. Again, what you put in there, it's what kind of matters in terms of device quality and capabilities. But these are the two different types of architecture and two different ways in which you can use these devices now. In terms of the network aspect, what's new? Basically, we support the same sort of network standards, 1 gig, 10 gig, for the hybrid architecture. The one thing that is new now in terms of the new all-flash architecture is that the all-flash architecture requires to have 10 gig interfaces only, as well as 12 gig controllers, right? And the reason for that is because we have to obviously be able to sustain the performance value that the platform delivers, and in order to do that, you need to have the right devices in place. For the most part,
hey,
we have a
Rawlinson.
lot of conversation. Yeah?
Yeah, so if if the recommendation is to use network I/O control, but what if I only have, standard licensing or whatever? I don't have licensing for the VDS.
I'm glad you stopped me in my rant here, GS, because I was on automatic. So good question. So what happens if you just have the standard license? Well, the thing is that when you license virtual SAN, part of its licensing entitles a user to utilize the distributed switch, which comes with network I/O control as part of your licensing agreement. Now, that is enabled for the particular clusters that are being utilized for virtual SAN. Does that answer your question?
Yeah, that's sweet.
Money in the bank, baby. So here's another big topic that a lot of folks we get into a lot of discussion. It's the use of jumbo frames in terms of being able to, configure that on the infrastructure. And to be honest, we talked about it before in the past with the release of 5.5. We said that from a performance standpoint on the network, it didn't really make that much of a difference, and almost none for virtual SAN. For the 6.0 release, once you start getting into utilizing the all-flash architecture, this is something that you may want to consider, just for the simple fact that now you want to obviously have reduce the CPU overhead, because when it comes to all-flash, you no longer have to worry about IOPS, because now you're going to hit all the bottlenecks. And being able to reserve and keep as many CPU cycles as you possibly can will make it better for your system. So in this case, whenever possible, we do recommend enabling jumbo frames, just for obviously being able to reduce the overhead in this particular case. Using either one of the distributed switches, as GS mentioned here, is supported, but the fact that you you're granted the licensing of the distributed switch and also being able to leverage network I/O control provides a lot of value into the solution itself. In terms of new solutions that are being delivered and enabled by virtual SAN, we're looking now into also enabling the blade market, but not just any blade market. we're looking into high-density direct attached storage systems in the form of JBOS. So we're talking about, specifically qualified blade systems that have access to storage nodes that then can utilize these direct attached storage devices per blade, so that you can actually leverage your virtual SAN infrastructure. Obviously, when you think about the purpose of blade systems, they were not really meant to be utilized in a sort of in an infrastructure where it requires the use of a lot of disks, right? Our blade systems don't have a lot of disks. These types of chassis, particularly the two that have been certified for virtual SAN, which are an IBM Flex system and the Dell FX platform, are the ones that actually are capable of doing this and are within our HCL today, can actually deliver a lot of value in terms of being able to use a sort of solution. And even if you have blade systems that have at least 2 devices per blade, we can actually have a solution where we can maybe satisfy some of those requirements and utilize that storage for any particular reason. Highly recommended for folks who stay very relevant and kind of look into the VMware, the compatibility guide in terms of the updates and things that we're doing with the new hardware components that have been added. We're doing more than just adding hardware devices and models. We're even looking at drivers and firmware, so that you can actually have a much better way of identifying which device, which firmware will allow you to get the most and the best level of performance for virtual SAN, depending on what you're using in your infrastructure. It's no secret that when it comes to the converged infrastructure in virtual SAN delivers the most capable and probably, I would say, the widest option for configuring virtual SAN. Number one, you have the a la carte do-it-yourself, where you can actually define and find all the components that you may need. You can take the approach of using the virtual SAN ready nodes out of any other supported OEM vendors that have different versions of the ready node, a device that's fully certified and all the components are guaranteed to work with virtual SAN. Or you can take the ultimate approach, which is the hyper-converged infrastructure approach. And in this case, you will use one of the Evo devices here, EvoRail, which delivers not only an appliance with a number of nodes, but also a completely fully integrated stack, which includes support as well as different types of capabilities and different values that are delivered by one of the components of that EvoRail solution. As an example, when it comes to sizing the new infrastructures, these new virtual SAN architectures, whether it's going to be hybrid or flash, here's some of the sort of intro profiles that you can kind of consider and look at for sizing the different types of configurations, whether it's going to be for VDI or whether it's going to be for traditional server workloads. We are providing a couple of examples that can be actually considered whenever you're sizing your solution. You can see some of those values that are here for either one of the approaches that you may take, whether it might be hybrid or the all-flash architecture. For VDI, we also do the same. Actually, here's some examples as well, whether you're going to take the approach of doing VDI on a hybrid architecture or VDI on an all-flash. For those of you that may haven't seen this, but not too long ago, I released a blog post with a demo that has a boot storm, which we performed the test of booting 6,401 VMs in 20 minutes in a 64-node cluster composed of obviously all flash in virtual SAN, which shows a lot of value in terms of just to show off what we can do, and showed off a lot of the capabilities of the new platform there.
Yeah, if you haven't watched that demo, I highly recommend it. It's pretty sick.
Absolutely. Try to booting up 6,401 VM in 20 minutes. Ready to use with IPs and everything. Yeah,
very cool.
Any questions so far, GSC? Is there any questions lingering out there before I kind of go back in automatic again?
No, nothing yet. No, nothing yet. I'll definitely.
Cool. I guess folks pretty much know about this.
Up, though. Yeah.
All right. Cool. Well,
and everybody, just a reminder, everybody, if you do have questions, please throw them out there. Rawlinson is the guy. Okay, looks like we just got one.
Hit it.
You know of any plans to support Go blades for SAN?
Say that one again.
Go blades. Okay, HP blades.
Huh? Are there any plans to what on the blades?
Any plans to support HP blades?
Sure. It's a matter of going through, I think we're doing a lot of hardware certification right now. The blades obviously will go through a process of certification. Now, if the question is in respect to the similarity of what the IBM Flex system and the Dell FX system is, I am particularly not aware of a system like that from HP, but if there is, you better believe we're probably testing or lining it up for two-way invalidation, because we obviously want to enable all of our vendors and all of our partners' hardware that is capable to deliver a lot of capacity in that sort of solution if they have it available.
Does that answer your question? If not, just let me know, and I can. And if anybody wants to ask a question verbally, just let me know and raise their hand, and I can unmute you. Yep, he's good. So
cool.
Thanks for the question, Zach.
All right. So a little bit about the performance and the scale improvements on the platform. So there's a lot that's been done. So for the most part, obviously, we're able to, have 2 times more the number of VMs per host, which is great. 100 last time wasn't enough, and we did that because of the component counts that we have to deal with, and obviously now we double that up. We now also support 62 terabyte virtual disk on the platform, so obviously it's another one that we're in compliance with the rest of the platform. It's something that a lot of our customers were looking to have. One thing that VirtualSAN delivers is obviously an improvement on snapshots and clones, and also the number of snapshots that can be created per virtual machine, and the number now is up to 32. From a host scalability perspective, the big thing here is that we are now able to scale a vSAN cluster of any architecture, hybrid or flash, up to 64 nodes, and that's pretty huge. When it comes to, if you get to scale a cluster to that point, that's a lot of potential storage that you can have depending on how it's designed and architected there, but there's a lot of power that comes along with that. In terms of the features, obviously, so there's a couple of key features that have been added in this release of VirtualSAN. One of them being this new on-disk format that we have, which is going from VMFSL to the new vSAN file system, which comes from a previous technology that we acquired from a company called Versa. As part of the process to get into that on-disk format, there's a procedure where upgrading for vSAN 5.5 to 6.0, we now have the ability to do that seamless in all lines. So there's no need to bring down any one of your applications throughout the upgrade process. This upgrade process is done seamless, and also in the event of a failure or in the event of any sort of dissatisfaction, there is the ability of rolling that procedure back to the previous version. Now, once you go forward, I don't think you want to go back, because the amount of performance improvement that you'll get, it's unparalleled when it comes to comparison of the previous system. From a disk serviceability functions, we've added a lot of enhancements to the UI, ranging from a data sync dashboard, being able to flag the devices from either magnetic or flash devices directly from within the UI, as well as being able to claim the devices as local when they're categorized as remote. From a platform perspective, there's a couple of things that are pretty nice and new. One, which I can tell you, is the all-flash architecture. The other one is the vSAN Health Check plugin, which I call it here vSAN Health Services, which actually is about to be released tomorrow. So everyone should be able to get their hands on that service, which allows you to do some pretty cool health check evaluations on your VirtualSAN infrastructure. There's a couple of things like fault domain support that allows you to identify failure across racks, and also the enablement of some of the other data services that we leverage through our third-party vendors, such as file services, encryption, and some other things that are there. For the most part, VirtualSAN is pretty open in terms of the amount and the type of hardware that it supports. For the different types of architectures, whether it may be SSD, PCIe, UltraDIMM, etc., all these different devices are supported for the different architectures and for the different tiers that now make up VirtualSAN. You'll be able to obviously identify the ideal device for your solution by looking at the VCG at any point in time. Now, in terms of guidance in configuring the all-flash architectures, we provided a lot of guidance with regards to the sizing, right? We talked about this 10% of the projected use capacity of the system. And that was for the hybrid. Now, we used the same kind of approach on the all-flash, but we take into consideration the size of the workload, the working set. And obviously, if you have really big workloads and the working set is going to be larger, you may want to consider increasing that 10% so that you can actually sustain a larger capacity and a larger working set within the caching tier when it's running in all-flash, as we now intend to keep all of that data in that caching tier all the time whenever it's active and hot. For the most part, here's somewhat of an example that we actually provide in terms of how to get to the calculation that matches that 10% and what it translates to. Right? So when we look at the projected space per VM, the number of VMs you're going to have or you expect to have in that particular cluster, you can see those numbers and exactly once the math is done, what that 10% also translates to. If you are going to be a big user of the snapshot, the new snapshot and cloning capability and retain snapshots for longer periods of time, another thing you also should consider is then possibly having a larger cache tier, larger capacity, because now obviously some of these snapshots can actually consume some of that tier as well. Here are some of the classification when it comes to the devices and what we classify them as class A through D. In terms of one of the values that we look at today with regards to their wear and tear, we look at total writes per day or total writes in 5 years. Obviously, each device has to have a lifespan that could, suitable for the enterprise when it comes to using some of these devices that we have available. Here's somewhat of an example, what you want to look at, and also you can validate that with the different devices you may have, and also take a look at what we have available within the VCG. One of the things that are new now to the all-flash architecture is the fact that we now have to define or flag the capacity devices in a different way that we did in the past. We do this through the command line interface to flag a particular cache device, a flash device, as a capacity tier device. And you can see there's two ways of doing it from the ESX CLI or even RVC. But we also have a community unofficial tool that I created with Brian Graff, which allows you to configure the same settings a lot easier from a web interface. You can even group the devices so that you don't have to, flag manually, hundreds of disks that you may want to use depending on the size of the cluster. This is something that you can download from my blog, punchingclouds.com, and use it at any point in time. It's a community tool. It's based entirely on PowerShell code, and it can be used at any point in time. Some details on this format that we have today. Why is it that this new on this format delivers better performance? What changed? Well, aside from some of the internal changes of the stack that we've made, this is one of the bigger pieces as well. This new on this format is able to still leverage the sparseness in place that was put together or what the VMFSL was based upon, but also is able to leverage a much better caching technology and caching capability, which is what actually allows us to deliver the new and better performance that's delivered in this new file system with Virtual SAN. That also introduces a new Delta disk, which in this case is called VMFS. When you compare it to the VMFS sparse, which obviously is set on redo logs, we all know and have experience dealing with VMFS and performance over time for snapshots and clones. Now this new vSAN sparse is able to deliver performance that is comparable to a native SAN snapshot. And how we get to do that is because we're now able to leverage more efficient and have better results when it comes to writing extended caching capabilities to the different devices that are within the Virtual SAN solution, right? And this is all delivered only when running on the new version of the file system. The upgrade procedure is quite simple, to be honest. It's done in 2 steps. Obviously, the first step is upgrading the vSphere infrastructure to obviously running it up to 6.0, including vCenter and then the ESX hypervisors. After that, you'll have to perform what we call a this format conversion where the upgrade, as part of the upgrade procedure would require to reformatting the disk groups and all the disks that are involved in there. But then at the same time, once that's done, we'll have to upgrade and reformat the actual objects. The beauty about this in phase one, you'll have the ability to obviously offload all your different workloads as well as the data by default. Obviously, being able to put a host in maintenance mode would allow you to evacuate the disk so that you can fully do it safely so that the risk of a potential data loss is not incurred. Obviously, we'll be able to offload all the data at a point in time. Obviously, depending on the amount of data that you may have, that can take some time. But overall, all your data will be safely evacuated. As part of phase two, once the upgrades have been done, the upgrade can be performed today from the vSphere RVC plugin. Obviously, you can see here an example of this command. It's a one command, one-liner. It's a one-time type of thing. You won't have to deal with it ever again once you perform your upgrade successfully, and you'll be able to kind of take advantage of all the benefits that are delivered by the solution. When it comes to the conversion, there's a lot of pre-checks that the system is going to perform to make sure that the upgrade goes as smooth as possible, that there are no hiccups. And before any of the upgrade procedure is started, the system will do all this validation and look at all of these different types of components and qualifications in order to minimize the risk of a potential issue so that we can actually do everything quite successfully. And as the last thing, you'll be able to roll back the disk format implementation if anything goes wrong. I've yet to see an upgrade go wrong, again, because the system does a lot of pre-checks ahead of time, and it allows you to make changes so you can avoid any potential problems when it comes to the upgrade started already. When it comes to usability improvements, let's talk about UI enhancement. One of my favorite features here is the fact that now you're able to actually evacuate the data from an individual disk or disk group without having to put a host in maintenance mode. You can safely do this. You can replace a single disk. In a 5.5, we had to actually place the entire host into maintenance mode to do this. That's no longer the case. This translates to operational efficiency, which actually makes it quite nice for users and customers to use whenever they want to either upgrade or replace a failed device. From a disk serviceability perspective, we have a couple of new little knobs here. Obviously, the ability to flag a particular device, one which may not be recognized as a flash device because of its connectivity from the SAS controller to the controller and the actual host and the type of interface that it may have. You may have to actually define that device as a flash device or a local device. You obviously have those capabilities now within the UI here. You can see that in the lower part of the screen. You also be able to light LEDs in the event of a device failure. You can now actually light the LEDs on failures. You can turn them on, turn them off, and actually point out which device should be. It's recognized as a failed device potentially, so that another admin can potentially pull out the right device without failing and not having any type of drive out of the system. That is the very last thing you want to do. From a usability standpoint here also, here's a what if API scenario that has been introduced into the framework for the policy creation. Now you can dynamically see the impact on the capacity as well as the resource consumption of the storage system, of the virtual SAN data store, and how it applied to it based on the policies and the settings that you're choosing for the different characteristics that you may want, whether it might be performance, capacity, or availability. As you build these different policies, you can actually see that dynamically on the right-hand side. One of the new features that we have available also now is the ability to define default storage policies. So previously, we weren't able to do that very in a type of an easier type of way in vSphere when it came to virtual SAN in 5.5. Now you're able to actually define a user-created type of policy and define it as the default policy for the different cluster. Not only can you do that on a single cluster, but now you'll be able to do that dynamically at any point in time and sustain that across multiple clusters within the actual vSAN server. Obviously, as long as multiple clusters are managed by the same vSAN server, you can now effectively attach an individual policy that delivers a different type of requirement and capability across the entire cluster to all these different VMs and objects, and still be able to sustain it across the different types of cluster in the vCenter server. You'll also now have the ability to identify the resource consumption on a per object, in this case per VMDK level. You can see the amount of cache consumption, the capacity, as well as the amount of storage used based on its availability, right? We know that failure should tolerate 1, 2, or 3. So you'll be able to identify here how much storage capacity is that actual object, or that disk in this case, actually consuming. Here's the example of using a 62 terabyte virtual disk, which is now obviously fully supported in virtual SAN. Another pretty aspect here is this, one that was only available in the command line, which was an RVC. What happens when you put a host in maintenance mode or you change a policy? You want to be able to identify how long is it going to take for the data to actually be completed, its synchronization process, or if it's smooth, right? Before in the past, we couldn't see that in the UI. Now we're able to see that directly in the UI Resync dashboard. You can see that per object, per host, how much capacity is left, and an estimated time for how long it'll take to do that across the entire cluster. One feature that I tend to like pretty much, obviously, is proactive rebalance. So this is designed to address a couple of use cases. Particularly in virtual SAN, we don't move data. Data gets moved around only in certain occasions, when there's a failure or any particular device reaches 80% of utilization. In order to avoid hotspots and in order to distribute and access the data as wide as we possibly can, the system will look to distribute and synchronize data in those two different occasions. Now, the 80% of utilization can happen at an unwanted or unwishful time per se. Let's say maybe prime time, key top hours of operation. In order to avoid that situation and potentially have an impact on the performance, because of the same network that's being utilized to send I/O to the data source also being utilized to synchronize data across the system, you can now actually proactively start a rebalancing operation from RVC. This feature is not available yet in the UI, but it's something that you can add and start it from the RVC command line interface. Not something that I would say you should use all the time, but obviously its use cases are identified here so that you can try and mitigate any possible performance degradation that may exist when something like that were to happen. Any questions so far? Anything, GS?
No, we're still good.
All right, I'm going to keep flying. So one of the new features that Virtual SAN is introducing now in 6.0 is the concept of failure domains. So now you'll find you have the ability of creating or defining a fault domain. Fault domains are going to allow you to survive or add knowledge to the implementation of rack awareness. So you can now withstand power failures, rack failures, physical network device failures, and such things. As you can see here, we can now take multiple servers and group them into a single fault domain, which is very different from the way that Virtual SAN.
Does this mean that I can do? Does this mean I can do like stretched clusters? Can I do my stuff?
Well, not necessarily. Not necessarily, right? Because this is obviously a solution that is a feature that is intended to be within racks. So introduce rack awareness. Now, can you look at it and think about it doing a stretched cluster? Well, that's not the intent or the design for this. And when you talk about stretched cluster, we're talking about having, two sites that are part of that configuration. For this particular feature to work, the way it's designed to be, a very minimum of 3 fault domains, which is basically almost the same thing as, the minimum number of nodes you need to create a Virtual SAN cluster. Now, you might be able to, within a particular cluster campus, put hosts in 3 different number of hosts in 3 different in 3 different buildings. Now, that's something that when you look at the VMware end user license agreement, it's in violation for that particular use case. It's not something that we recommend, as it is not designed to be that. But those are things that, if you do it, will they work? Yes. But again, you'll be violating your EULA And if something were to go wrong, you're going to have to work with VMware support, how to actually address that. Particularly when it comes to, yeah, Jeff, any question?
I was just saying, yeah, that sounds good. I would imagine that that's not going to be that way for that long, though, right?
No, absolutely not. So we're working on a solution to address that as a potential feature, as a potential roadmap feature for later on.
Awesome.
Cool. So here's one of the things that are pretty unique about fault domains, which aside from the availability factor, it also allows you to make a little bit more effective use of storage capacity. So in this example here, in this diagram, you can see that we have, for example, a virtual machine that has a failure to tolerate equals to, which means we need 3 replica copies in virtual SAN 5.5 to provide the actual compliance on this policy in the event of a failure. And the way we do that is because we have the whole witness concept, and we have to obviously make sure that we have, N+2 in this case, when it comes to providing protection for this particular server. You can see that it leads to 3 replica copies, 3 mirror copies, of the actual data. Now, the impact of implementing the same type of solution, the same type of policy on a virtual SAN cluster that is using fault domains, you can see here that it now reduces the amount of data that is consumed, because instead of using 3 replicas, now we have 3 replicas or 3 mirror copies of the data, because with fault domain, you can actually guarantee onto which node the components in the data of a particular virtual machine's object will be replicated onto. So here's how you're actually able to guarantee from within the software and define where you want your data to be replicated onto in respect to number of fault domains. You don't have the ability to dictate the host and the disk per se, which the system does that, but here at least we have the ability to guarantee that the data will be distributed across different racks in the event of a rack failure, and at the same time you're consuming less capacity because you can guarantee that availability without having to consume more capacity. The creation of the fault domains can be done very simply from multiple places. It can be done from the web client, ESX CLI, and even from RVC. Here's an example where you can see how it's all done. Basically, drag and drop, create your fault domain, define your rack settings, and that's all you have to do. Everything else will happen on its own. To create it from the ESX CLI command, this is actually a pretty simple command, and you can see there how it can be done. You can identify, set it, and identify the value that you may want from each host. But fault domains could actually also be configured as part of our profiles. You can see how that can be done with the different profiles you may have as part of the build out of your host. Those profiles in this case are very useful in an environment where that's standardized, and virtual SAN is one of the options that's available there. When it comes to being able to configure it from within RVC, it's one of the vSAN commands. You can see some of the examples and some of the outputs here. You can actually have a lot of flexibility when it comes to doing this. If we start doing this from, in large environments as these virtual SAN infrastructures continue to grow, doing it from the GUI, it's always not the most effective way to doing that because we want to be more efficient and be able to do that across multiple systems. One thing that is new here now in Virtual SAN 6.0 is the way in which we now calculate for availability in terms of the quorum computation. In Virtual SAN 5.5, each component had only 1 vote, right? In the essence that, if there's a failure, there may be an additional witness to equalize the votes. In 6.0, we've changed that algorithm where now each component initially has 1 vote, and vSAN may increase the number of votes for certain components, equalize the votes. So basically, instead of having a particularly defined witness file, it might just be up to a voting process. So in Virtual SAN 6.0, what happens is that you may be able to see or may be able to have a witness file, a witness object or component, or you may not. And it's perfectly fine because now, as you can understand, depending on the availability settings of the particular object, this new sort of quorum computation will come into play as we now have totally avoided the previous one in terms of doing the file witness copy. Now, in terms of interoperability, there's a lot of different things that interoperate with virtual SAN. Obviously, we leverage data services as a platform. The fact that vSAN is integrated to vSphere, we can leverage all of our partners' ecosystems capabilities on some of the data services that we may not have natively. For example, file services. File services are delivered through solutions like Nexenta Connect for virtual SAN, a solution that is developed by Nexenta and allows us to deliver SMB and NFS file services outside of virtual SAN through an appliance. This appliance, the solution is obviously defined and created to leverage all the different capabilities and values introduced by virtual SAN, including SPVM. So for those of you that are interested in using, being able to expose virtual SAN capacity outside of virtual SAN, outside of the virtual SAN cluster, from a file services standpoint, these types of solutions are the ones you can utilize to achieve that. From a VRealize Automation perspective, VRealize Automation can actually interoperate with virtual SAN when it comes to the consumption of.
Hey, Rawlinson,
being able
you have
to
a question.
Identify different policies. Yeah.
On fault domains, so do fault domains modify HA host isolation behavior?
Say that again. Does fault domain?
Yeah, do fault domains modify HA host isolation behavior?
So obviously, virtual SAN is totally integrated with HA. And the two systems obviously know exactly where the objects are placed in order to maintain the availability factors across the way. So they're totally integrated. Nothing changes beyond the way they should behave. Still, if there is, for example, a rack failure, right, HA will still be able to bring up the virtual machine onto the other rack as long as there's obviously capacity and the resources available. So everything is tightly integrated and remains the same in terms of functionality with HA. That's the question.
Yeah, they said thanks. Yeah, that was Brian. Thanks for the question, Brian.
There's a lot of work that's been done to make virtual SAN compliant and compatible with HA, because if you think about it, virtual SAN provides availability from a device failure perspective, where we also need and provide software availability perspective. So obviously, if the host fails, we can't just ignore the VMs that were hosted there on that host that fails, right? Those will obviously have downtime, but now we have at least the ability of being able to bring them up on a surviving rack or host that is part of that configuration. And in order to do that, HA and vSAN have to work very tightly together so that we don't have a split frame behavior where there's objects here and the different fault domains in different places in order to, because that'll obviously fail and not work correctly. So we actually did a lot of work to sustain and maintain that level of integration and capability so that we will not sort of screw that up in that particular aspect. Cool, we keep moving. So one more thing on VRealize. So obviously there's a plugin that I developed before, which you may have seen or may have heard of in the past, something I started calling Project Magic, which is what actually delivers SPVM integration into VRealize Automation, which I sort of developed specifically for virtual SAN, but now obviously I've evolved it to more than just virtual SAN. It works with virtual volumes and our entire storage stack. But when it comes to virtual SAN, it's able to actually integrate very nicely together there. And you can see how that can be easily utilized when you use that sort of service model operation approach. Virtual SAN is obviously, interoperates with VRealize Operations. I believe we already announced a beta program for VRealize Operations in Virtual SAN 6.0. If you haven't heard of it, you probably need to see there was an announcement on the vSphere storage blog. And obviously we're looking into moving a lot of the things we've done with, we do with RVC, obviously command line, it's also UI, and now bringing it directly into VRops. Being able to leverage things like smarts, being able to identify the health, identifying the root cause, analysis, being able to do all of the different things that VRops is able to deliver as a product but now revolve them around virtual SAN, which is pretty nice. You'll see a lot of that coming up very soon. We're getting ready to put a lot of collateral out there around some of the things that virtual SAN can now, or a lot of the things that VRealize Operations can now monitor. Kind of like myself, I wish I knew more, but I have Alan. We have a lot of different capabilities that can actually be accessed here. Oh my God, I love Vegas. So in terms of integration and the rest of the products that are available, here we have, you can see how some of the different components interoperate with virtual SAN as a disaster recovery solution for the software-defined data center. Virtual SAN being one of those components from the source perspective, but obviously vSphere application, vSphere data protection, SRM, and vCloud Air disaster recovery all interoperate and work pretty nicely with virtual SAN and can still be leveraged as any other solution that works seamlessly with virtual SAN at any point in time. For monitoring and troubleshooting, obviously we have some commands that have been introduced to RBC. Some of them are new. Some of them are not. Some in particular are here, like the one at the top, which is the one that enables and kicks off the upgrade, the undisk format upgrade. Some of the other ones obviously help you manage and wipe the disks that you may be using, either for vSAN or non-vSAN environments, to make sure that we wipe them and clean them correctly before we put them back into the system. So there's a lot of different things that have been added on the RBC side of the house. And in particular here, this is one huge piece of effort in terms of a feature, which is the vSAN Health Check-in plugin, which you'll see fairly soon. And I'm going to just go out there and say this. You better check the VMware site tomorrow because we're probably going to be releasing some hot stuff around this little tool right here. You'll be able to sort of conduct and perform validation scenarios in terms of the configuration of the system. You'll be able to see and report troubleshooting scenarios around not just the cluster health, the network, the data, the limits, and also the physical disk. But one of the most important things and one of the biggest achievements in terms of being able to add it to this particular tool is the ability to consistently check compliance with the hardware compatibility guide in the VMware compatibility site. That's going to be pretty huge. So you'll be able to actually update and always see, and the system will be able to report whether or not you have access or you have the latest version of the hardware, the drivers, the firmware. All of those things are now being tracked and mapped directly by this tool, which will be available starting tomorrow. This is going to be huge. One of my favorite tools or features enabled in the product, which will help customers immensely in terms of making sure that the system is top-notch and is healthy and able to deliver the goods. And with that, folks, I think I'm done. Any more questions, I'm here for you. So you can catch me, swing them to me on Twitter, and I'll be happy to answer them.
Okay, so we got a couple of questions.
Sweet.
Let's see, is it as simple as inserting additional disks to expand vSAN? In other words, if I have 6 bays and I start with 1 SSD and 2 spinning disks, can I add another SSD or spinning disk to the host and have it usable on the vSAN storage pool?
Absolutely. One of the key values of vSAN is this is a solution that you can scale linearly. You can do it per host, per magnetic disk, per disk group, in any way fits your demands. Whether you want to scale it for capacity or performance, obviously the approach that you'll take there is either, if you want to scale for performance, you have to introduce a caching device and a capacity device, or if you want to scale it from a capacity standpoint, as long as you have space within a particular disk group, you can do that just like that, one at a time.
Cool. is storage-based policy management all based on user-defined vSAN capabilities, since there isn't a VASA provider, or is there?
So we leverage VASA as a way of exposing and surfacing the capabilities that are delivered by virtual SAN. Obviously today, virtual SAN's capabilities are software defined and controlled by us, our solution, what we implement it. Now, the policies are user-based, they're created by user, which in a way, you know, we have 3 different types of capabilities. These capabilities have individual values that can then be combined into what we call a policy. Once a user defines those capabilities, they're saved into a policy, then the system is able to now do that. Now, the value here is this. We're able to have a 2-way conversation with the storage solution that we're delivering in the vSphere stack. Because one, I can recognize what the storage system, what the storage solution can do for me as an application, and then I can tell the storage system what I need to consume as an application at the storage layer. So that 2-way communication is made possible through the VASA API.
Great. Okay. Last one is NVMe fully supported for vSAN now? For example, Intel P3700, including Dell version of firmware. I was just going to say check the HCL. So.
Yeah, funny you ask that, because also, so obviously I'm at EMC World right now at this hot smoking casino where there's a lot of action going on. But one of the things that I brought to EMC World to showcase, which I'm about to go from right here, is a 32-node cluster full of NVMe. We partnered up with Intel to do this. And while NVMe devices are not yet there, you better believe that we're working on the certification process for that right now, because the devices that we currently have in this cluster that I'm about to go see over at the Solution Center, which from what I understand, it's like frying the switches. It's basically, you can smell the smoke coming out of it.
Yeah, I've seen some tweets about that already.
Yeah, yeah. So you know, those devices will be supported, and it's a matter of time. You know, we're going to support it. That's coming. It's just a matter of getting the actual vendor-specific devices supported. Obviously, Intel is going to be one of the ones that are going to be first on the list because of the obvious reasons that we're already doing it, right? It's just a matter of us finishing the QA process and putting it on the HCL.
Great. So that's all the questions.
All right. Well, I'm sorry that I was late. Obviously, what would you expect? You know, would you expect anything different from me?
Yeah,
I'm obviously at you know, I'm obviously at EMC World, you know, in the middle of a casino. This is the first. Last time I did a podcast, I did it from a bathroom toilet. This time I do it live from the casino over at where am I? The Palazzo, sitting in front of a vending machine here, just kind of doing what I do.
Awesome. Well, thanks, Rawlinson, and thanks everybody for attending. This is the vBrownbag. Join us on Wednesday, May 6th. We're going to be talking about, I don't remember what we're talking about, but got more vBrownbag business coming up, and lots more vBrownbag every week. US, EMEA, APAC, all of our different shows. Listen when you can, join live, ask questions, or check us out on iTunes. Thanks, everybody, and we are out.